Hi, my name is Sahan Karimi, and I'm AIMO's engineer working on the frequency performance payments reform. This video is part of a series that AIMO has produced to help stakeholders understand the FPP reform. Each video focuses on a different aspect of the new arrangement. In this recording, I'll be explaining the unit deviation and residual. The information I'll be presenting is intended for a broad stakeholder audience and is an overview only. We recommend that participants should read the Frequency Contribution Factors Procedure, FCFP, to understand more details. An important step in the FPP calculation process is determining the deviations of units. The deviations of each unit are basically the difference between the power output and its expected generation or consumption, which we call reference trajectory. So a unit's reference trajectory shows its expected active power output or consumption. The reference trajectory of scheduled and semi-scheduled units is a straight line between the previous and current dispatch targets. The reference trajectory of non-scheduled units is a continuation of the unit generation at the start of the current trading interval. This figure shows how the reference trajectory of a coal power station is determined by using its dispatch targets. You can see the trajectory is a simple target-to-target straight line in each trading interval. AIMO calculates 4-second unit deviations in megawatt by comparing unit power output against its reference trajectory. Similar to frequency measure, unit deviation is calculated at each 4-second interval. A positive deviation is one that increases the net amount of energy in the system, or basically more generation or less load. You can find more information about the unit deviation in sections 5.1 and 5.2 of the FCFP. In this figure, we are showing power output of the unit and its deviations in addition to its reference trajectory. As you can see, the deviations are simply the difference between the reference trajectory of the unit and its SCADA power output. Finally, this figure shows only the deviations from the trajectory. This data is used later for calculating the performance of the unit. Moving on to residual. The residual in the FPP refers to all facilities connected to the grid without appropriate real-time telemetry, or basically 4-second SCADA measurements. This includes small consumers and distributed resources. AIMO calculates the residual deviation in each region as the opposite of the deviation of all units in the relevant region. To do that, we sum the deviations of all units with appropriate metering, then take the opposite of that sum to determine the deviation of the residual in that region. Here, as an example, we show the step-by-step calculation of the residual in Tasmania. This figure shows the sum of all positive deviations and the sum of all negative deviations over 8 trading intervals. So the sum of all deviations with appropriate metering will be as the orange line shown in this figure. Finally, we take the opposite of that sum to determine the deviation of residual in Tasmania as shown by the green line in this figure. I hope this information has been helpful. In the following videos, we will focus on a different aspect of the FPP reform. If you require more information, please visit AIMO's FPP project page or email us at fppconsultation@aimo.com.au. Thank you.